Okay, gentlemen, just a quick video for us to look over before we do our homework 2.9 we're up to, or 2.8, whatever. But this is the async that we did in Desmos, and these are the notes we wrote in class about domain, continuity, y-intercept, which were basically from class, the Zoom snow day. And then we talked about our full definitions of horizontal asymptotes, and then we reviewed increasing from last week. And then we kind of gave formal definitions for max and mins. Right, so based on all these notes, remember, maxes and mins, all of them are local. Only the absolute tallest or lowest point would be an absolute. If there are any, there may not be any. Okay, your vertical asymptotes are at x values, horizontal are at y values, and then this is all y, or how they occur. Okay, so looking down, this is what our slide number 4 was, and I just kind of want to go through all the questions kind of in order, or all the description qualities we had. Now, I wrote them in a different order. You have on your Desmos domain, and then it says range. I put that at the bottom because it's kind of the hardest to find, and right now the least important until we learn inverses. And then it was x and y intercepts. I put continuity up here because it makes sense for me to put it up here. And then I put vertical and horizontal and increasing, decreasing, max and mins. Those 4 are related. So instead of having increasing, decreasing, then asymptotes, then max and mins, I put these 2 together, asymptotes, because that's related to continuity and domain. Increasing, decreasing, the points where I fluctuate are my maxes and mins. So I like to write it in this order. Doesn't mean you have to, but this is probably the way I'll kind of mentally do it most of the time. And those top 3 things, domain, x, y intercepts, and continuity, are in our mind the most important. Okay, so to make this video short, domain, I look at the bottom of that fraction and I could see factored x minus 3, x plus 3. Easy. 2 numbers I'm skipping here, pretty clearly can see, are positive and negative 3. So I go from negative infinity up till negative 3, then from negative 3 to 3, and then from 3 to infinity. Domain, nice and simple. We've seen it a bunch of times, based basically solely on the algebra. Now, x-intercepts, we're not really sure how to find them for functions like this yet, rational expressions, because we have to kind of set the whole thing equal to 0. Then how do you solve that? Not too sure yet. We'd have to kind of finagle it. But we can kind of look at our graph on the right, and we see that there are none. Very nice. Y-intercept, as we said, the y-intercept occurs when x is equal to 0. So if I take my function of x and I say, well, I want the x to be a 0. So here's my function. Everywhere there's an x, I put a 0. And then those cancel out, so I get 18 over negative 9, which is just negative 2. So my x-intercept, or my y-intercept rather, is 0, negative 2, and we can see that on the graph. So first 3 should come relatively simply. Continuity, well, clearly looking at my picture, I am discontinuous. And it looks like I have some vertical asymptotes, but let's just check by factoring the top part of my fraction. Put my little arrow up there, take out a 3, x squared plus 6. Nothing can cancel, no factors can cancel. So that means just the 2 numbers I'm skipping, 3 and negative 3, are infinite discontinuities at negative 3 and 3. At x equals negative 3 and 3. And we can see that right here. Here's negative 3, and here's 3. Vertical asymptotes, those occur where I have infinite discontinuities. So they are at negative 3 and 3. These are them. I have 2 of them. They only occur at infinite discontinuities vertically. Horizontal, we know our rule. It says it's based on the degree of the numerator and the degree of the denominator. Since the degrees are equal, they're both powers of 2, I look at the coefficients. The coefficient of my x squared on top is a 3. Coefficient of the x squared on bottom is a 1. So my horizontal asymptote is at y equals 3, and it looks like it is. Increasing, decreasing, a little tricky because there's all these gaps. But basically, we got to skip the numbers we're not allowed to use, right? We're not allowed to use them, so we're skipping 3 and negative 3 always. I'm increasing all the way left to right, upwards. to -3, skip that number. Once I pass -3, I just start going upwards again up until the x value of 0. And then on the other side, I'm over here, and I'm going downward, right? So that's obviously some sort of a point for us. Over here, I'm going downward, so from the x value of 0 up until 3. And then what happens on the other side? I'm going down, 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 down. If I kind of look at this, if I were to have this in Desmos, you would see the numbers are getting gradually smaller for the y value, meaning as I'm going to the right on the x value, the y values are getting smaller. So I'm also decreasing from 3 to infinity. This is my only point I'm looking at. Clearly, it's a maximum locally, because it's a peak right here. But is it the total tallest point? No, clearly my graph gets taller, so there's no absolute max. Is there any minimums? No, my graph is going downward forever, so no local mins or no local or absolutes. And our range, the only thing that really matters for our y values outside of my y-intercept is I'm going upward. Both sides is fine, but then I hit -2, my y value for range, and then I don't use anything in this area until I pick back up around wherever this is. Oh, we found where that was. That was my horizontal asymptote. So after -2, I don't use anything until I'm at 3, my horizontal asymptote, and then I go upwards forever. So my range is from -infinity to -2, which I use that number. And then I skip at 3. I don't use 3 because it's where an asymptote is. Upwards forever. Range is a little tough. I wouldn't go crazy with that. But these first 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 things we should have relative ease doing. Okay? So hopefully this video is helpful. Go listen to that Zadi album that comes out on the 17th or the 19th. February 19th. Don't miss it. Zadi. The 19th all day. 24 straight hours.